Welcome all. Now I am going to discuss question number 17 from the GATE 2021 EC paper. The question is, consider the vector field F is equal to Ax into 4y minus C1z plus Ay into 4x plus 2z plus Az into 2y plus z in a rectangular coordinate system x, y, z with unit vectors Ax, Ay and Az. If the field F is irrotational, conservative, then the constant C1 in integers is. To know the concept of a vector field to be irrotational, audience can go through the given NPTEL video link.
Let us discuss briefly the field to be a irrotational. A field F is irrotational or conservative if its curl of the gradient is 0. The condition for irrotational or conservative is defined as del of del phi is equal to 0 and it is calculated as follows. For example, vector field F is equal to Ax into F1, Ay into F2 plus Az into F3, which is also can be written as Ax into phi x plus Ay into phi y plus Az into phi z, where Ax, Ay, Az are the unit vectors in the direction of x, y and z respectively. And the curl of the vector field F is calculated by taking the determinant of this matrix. Using this data, let us solve the problem. In the question, it is given that given vector field F is equal to Ax into 4y minus C1 into z plus Ay into 4x plus 2z plus Az into 2y plus z. As we have already seen, the curl of the gradient, the curl of the F is calculated as the determinant of the following matrix: dou by dou x, dou by dou y, dou by dou z. Here F1, F2, F3. So, I, J, K, dou by dou x, dou by dou y, dou by dou z. Here z component is 2y plus z, y component is 4x plus 2z, 4x plus 2z, x component is 4y minus 7z, 4y minus 7z. So we need to take the determinant of this matrix and we should equate this determinant to 0 to find the value of C1. So, I into dou by dou y of 2y plus z minus dou by dou z of 4x plus 2z plus j into, not plus, minus j into dou by dou x of 2y plus z minus dou by dou z of 4y minus c1z plus k into dou by dou x of 4x plus 2z 4x plus 2z minus dou by dou y of 4y minus c1z. So if we simplify this expression, I into 2 minus 2 minus j into 0 plus c1 plus k into 4 minus 4. So I into 0 minus j into c1 plus k into 0 is equal to 0, because if the field is irrotational, the determinant of the above matrix should be equals to 0. Here I component is 0, k component is 0, which implies that j into c1 is equal to 0. J is vector field direction, right? So j won't be equal to 0, implies c1 is equal to 0. So for the field f to be irrotational, c1 has to be 0.
So the constant C1 is 0. Thank you.